Yeah, my name is Raj. I work for Panasonic for almost 27 years, but I'm on an engineering side more of than sales. I'm in sales engineer, so technically we are all selling all the time. Today we're trying to discuss the ST2110. Anybody has any idea what this is, or little idea, or heard of it, or a little bit? It's basically design. This picture gives you a correct way. It's converting your STI into IT, but there is no such thing exists, okay? Not yet. So that's what the whole idea of ST2110. You basically convert your STI video into the IP-based structure. And the idea behind making ST2110 was SMPTE, Society of Standards, Motion Pictures and Television's engineering standards. So they designed standards for futures with the ST2110. So how to transport video, audio. So we're going to go through that, and we're going to show why it's that. So it's not just one standard, and it does not owned by anybody. It's Society of Motion Pictures, so it's a .org. So it's not a Panasonic or Sony or anybody's brand. ST2110 is a standard. Anybody can use it. Have you seen a BNC connector? You know how old that standard is? More than 80 years old. 80. And that was standardized 80 years ago because you can plug it in anywhere, the cables. That's the idea of standardizing it. So ST2110, I guess, next 80 years will work, unless AI takes over or something like that. But it's basically defined as basically you have to physically move your content or your video or your audio or something from point A to point B. And we've been doing it with the RCA cable in the beginning. Then we started with the composite video. How many guys remember composite video? So the composite video, and then STI came in. As the advantage of STI was it has audio and video both in the one package. Then they added in the STI video all the 3G and 4G, 6G and 12G and everything in the STI video. And STI video has both way transportation done for the audio, for the video, for metadata, everything you can put it in. So it was pretty good. It lasted. The only problem is the length. As you go from 3G to 6G to 12G, the length of the cable started shrinking. And then instead of having 4 or 5 video input, now customer is expecting 50 inputs, 60 input. They want to route it everywhere. And it's not practical with STI anymore. So that's why the need for ST2110 started, and I think this was 5 years ago they standardized it officially. So just early introduction of IP into live productions. We'll cover IP for remote versus IP for routing. So this is two different words. One is just streaming and one is routing. And ST2110 does both. That's the beauty of it. And the third party was gigabit LAN. That just came out, 5 years ago, gigabytes came in. Now it's 100 gig. Even 400 gig LAN is possible now. But I came from 56K modem days. Anybody remember that? The DSL lines. So that was the IP, but now the IP has now involved and control and manage, and And I remember that first time video came in IP world, they were saying, oh, this is 25 megabits. And the IT guys would say, my whole email server is 25 gigabytes. Yeah, but this is like a 1 minute of video is 25 gigabytes. So that's the difference in the data packet size and everything. It grew so big. So now it's crazy. So scaling down for the ST2110 for broadcast market, and we'll talk about some of the compressions are used in ST2110, JPEG access and IPMAX. Okay. If you have questions, please feel free to ask. No problem. We can stop. So STI, what was the advantage? Easy to replace from analog to composite to digital. SDI is digital. It's called serial digital interface. The composite was not digital. It was actually a component video digitized. So it was composite first, then component, and then came the SDI that combines all the audio and data and everything else in there. And it lasted for what? 50, 60 years, I guess. 30 years for HD SDI, I think. Before that it was there. Anybody remember FireWire? So FireWire was just a codec transfer. So actually you can say that that was the first time we are transferring content without lossless content transfer, because it was codec based. It was not a video based. It was codecs. IEEE 1394 was there. It worked very well, and it maintained the quality. You can make 6 copies of IEEE 1394 without losing any quality on it. So that was a compress over IP. And then RTSP and RTMP. RTSP was basically started as just a streaming video for the computer people. And then we came into the pictures and we say, oh, this is not a good video. We need better bit rate. We need better quality. And we started complaining about the RTSP because we are video guys, and it started by the IT. So it's a compressed video. It is also considered a stream. And then there is another standard came out for the AV part of it, HDMI and DVI. So the difference between HDMI has an EDIT to identify what kind of signal it is, to identify, again the same distance issue came in with the HDMI. Nowadays you can find a 250 feet HDMI cable with 4K signals easily. It's actually, matter of fact, cheaper to have a 4K 60p HDMI cable than a DNC 12G cables. So HDMI has evolved. The biggest issue with HDMI is there was no BNC on it. So there was no locking mechanism for the cable, and cable used to get loose, and that becomes an issue. Oops, sorry. It went too far. Okay. So with IP media, they needed a protocol. They need to standardize everything, so everybody talk with each other without any issue. Just like FireWire first time came in, it was just a codec. You have a DV codec or DVG Pro codec. Those were the codecs using FireWire used to get transferred easily. But it's a standard protocol. So protocol was very, very important. But SDI hit their limit with the 12G. I have seen an 8K video by NHK 10 years ago with 26 SDI from the camera to the player. It's crazy. They could not make it longer, but it was at NAB shows. They were showing the video on it with 26 cables, SDI. 12G cables, has to be high quality. to produce one 8K video. That's just not practical, I should say. So that's one of the reasons 4K and 8K didn't work that well. Let's not go. So latency was also an issue slowly. STI latency was the minimum. So then came our PTZ camera with the RTSP stream. HE50 was our first camera with RTSP stream. It was just providing RTSP stream. Now we have H.264, H.265, 4K, RTMP, SRT, MPEG TS, all kinds of stream built into the camera for encodings. And also the second part came in was the PoE++ and PoE+. So power over Ethernet become very powerful. It made to transfer video easily, integrating, just plug in one camera, it's easily, everybody use their security cameras at home, just plug one Cat5 cable, it power over Ethernet, and you have a stream coming out of it, and you can watch it on a phone or something. So that's that was one-way stream going out from the camera to the cloud or whatever distribution parties. But it's not built for the in-house productions. It's just one camera streaming somewhere. You got to build the whole ecosystem. Oops, oh, the wrong way. Am I going the wrong way? Yes. I'm going the wrong way, sorry. So STI's biggest challenge was routing. And as you know, the routers become costlier. And as you have to make 50, 60 video feed route, the space on the back panel becomes smaller and smaller. You know, for one rack unit, you can only hold that much BNC cables and route it. So for the router, that becomes a challenge. So routing was a problem. Multicasting was a problem. You have one STI cable for one output. There was no, you can't have 100 output out of one STI cable. You got to route it. Also, the scalability was an issue. Doing the transcoding between the formats, that becomes an issue. STI is, whatever you feed in, that's what you get out on the other side. And the biggest challenge was the computer industries are good. What good for is they call it off-the-shelf parts. For example, we started a P2 long time ago, when first time P2, if anybody remembers, it was based on the cards, commercially off-the-shelf SD cards. In the initial days, it was 2 gigabyte SD card was $2,000. And now you can buy 512 gigabytes card for the same $2,000. And that's because SD card has become available. Things become cheaper and cheaper, and it's easier to manage and install, financially possible. Same thing happened with routings and everything. It becomes very costly, but if you go to the IP-based routing, then it becomes easier because it's available off the shelf. For example, your 1 gig router, before it was 100K, right? The switch, network switch, 100K network switch was $69 or $129. I think last 5 years is now 1 gig switch is $69. Now there is a 10 gig switch is available easily. So the price scale goes down much more faster. So IP-based routing, the first job is to route the video, because STI routers were A, expensive, and B, it was not easy to do routing with inexpensively. So ST2110, they have to make everything route through the standard network switch. And in order to route the video, they have to make everything talk to each other's, and everything can be easily routed through your software-based network managed switch. And that was the biggest challenge ST2110 has. Oops. So once you address the routing, you have to build the whole system. The number one requirement always is a cost. Obviously, everybody wants everything free or cheapest possible. Right now, you can get a PTZ cameras with a network switch and a computer with the browsers. You can manage and control very, very inexpensively on a table. So the second part was Gigabit Ethernet is now minimum requirements for ST2110. If you're going 4K, then you do need 100 gig, even higher than that because of the bandwidth. We'll talk about it. And just standard tools that are available for software-based network management system that's already there in the network world. So we can use that also. So routing tool, and in the beginning, they started thinking of compressing it because 100 gigabyte network switch was a little expensive. So they say, hey, if you can compress the video a little bit, then you can actually get a cheaper switch, 1 gig switch, and you can transfer the video, and you can transfer the control, and you can transfer the routings, and everything can be done within 1 gig. And they have tried that, but as I say, it's the market dictates, and market started, reducing the price on a gigabyte switch, and your whole idea and planning it for 1 gig switch went out the window because now 10 gig switch is same price as 1 gig. So it's hard for a vendor to make sure that you're planning it for the next 5 years. And by the time you plan, if the switch becomes so cheap, then you don't need the compression. Then you don't need to have this. So they have to make sure that why it's changing, it's on its own. Keeps on changing, sorry. So another issue was latency. In video world, latency is an enemy, particularly if you have an iMac in a church or in a boardrooms. iMacs, your lip sync issue will be a problem. So if you compress the video, you have to uncompress it on the other end. That means you encode it, you have to decode it. The encoder and decoder cost the less latency. And latency was the biggest challenge in IP world. Because in order to transmit, they have to compress it. And in order to compress it, they have to uncompress it. Now you're adding both side latency of compressing it and uncompressing it. And that was the biggest challenge. ST2110 tried to address that challenge with putting an uncompressed video from end to end. Any questions so far? Other than why my presentation keeps speaking? So before ST2110, NDI becomes very powerful because it was auto discovery, it made life easier. You connect the network, it automatically tells you which camera it is, which company it is, what model number it is. So it has auto discovery tools built into it. And that was the advantage. The disadvantage was it's compressed and you have to uncompress. Even though the full bandwidth NDI was much less compressed than normal SDI, but there is a compression. There is a light compression, and that light compression adds delay at both ends. So that was the issue, but people were willing to go for it because for your iMac, this delay was manageable. There was a delay, but delay was manageable, and it made life easier for routing the video with NDI. You just hook up your cameras straight to your switcher over the network. You don't have to run a line or nothing, and picture showed up, and you knew which camera it is. It made life much easier. NDI worked. So next step would be to 2110 native device. That's another issue. Whenever you make something, you have to convert everything into. So SDI was always there, composite. That was cheap for many years. So you just connect the SDI video, HD video or 4K video, whatever video, you just connect a BNC cable and you're there. There is no compression, uncompression needed. With NDI, you connect a network cable, you have a video on both sides. The problem is you need a tool to uncompress it, to read that video that's coming through that network port. ST2110 reduced the cost slowly, but it's getting there. I think last year it came into the pictures now, a lot more than before. Oops, again, wrong one. So NDI LAN-based productions was pretty good for most of the workflow. The biggest issue was routing the video. You put everything on a network, but you could not route the video and you could not isolate the video. So you needed a gateway, and a SDI gateway was not there, and because of the compression, some people didn't like it. The quality questions comes in because it's not on uncompressed signals. And other issue is it's easy to connect at the same time. Sometimes it overloads the network system, because if it is only 1 gig switch, and in initial day people thought that any switch will work and it's fine, and buy any switch, and the switch buffering used to kick in, and there was lag in the video, and it's all because of the network switch, or people didn't know. If you put too many network devices on the same network, it used to cause a delay, and it used to cause lockup. So all these problems started to show up, and then people started to get frustrated. It worked ideally in a small network, in a closed network, but now COVID hit, and people wanted to go over the network to the other side of the universe, outside their campus or something, and then it becomes a challenge, because you need a lot more compressions, you need a lot more speed, and you need a stability. And that's why there are new standards came in, like SRT and others for streaming part of it, but all they didn't have is the routing. Routing part of the video was not there. So that's where the ST2110 came in. Oops. And ST2110 had the routing model. So that was their biggest advantage. And ST2110 has as I said before in the first slide, that it's a group of standards. So it has an audio standard, it has a video standard, it has a metadata standard. Every standards can be applied. and can be managed over the networks. And it had the gateways built into it. For example, our Panasonic cameras have now directly SFP built into the, say, PTZ. And you can take the network out straight out of it, ST2110, and route that video without any requirement of plug-in or BNC or anything else. So it does have NDI also on the same network, but people prefer ST2110 because you can have a return video on it too. So NDI is always one way from camera to the device. It can communicate for the control part of it, but that's about it. Whereas ST2110, I can send from the routers back to the camera a video, return video on my PTZ. So you can put a prompter on the same PTZ or the same one cables where you can have HD on it, you can have a return video on it, you can have a prompter on it, or you can have your what else? Teleprompters. Communications also can be done over the same 2110 SFP. So one SFP solves the problem, and its routing becomes easier because now you just put that SFP on a network, local network, and now you can route the video and audio and a control, and your return video also comes in. So that all routing and gateway becomes much easier. We have a cameras that does it. And you can also bring in the RTSP stream feed. You can bring in the NDI stream. You can bring in the SRT stream. Yes. Thank you. Why it switched it on its own? Am I static or something? Maybe my personality. Thank you. So switcher, mixers, everything has a gateway. We have a switcher called Kairos. Kairos is based on also ST2110, or you can bring in SDI and it will convert it. So the beauty of Kairos and the switchers is you can have both worlds, best of the both worlds, meaning you can have your SDI world into it, or you can have ST2110 network world. So when you are in ST2110 network world, you have to follow the ST2110 protocols. So routing and gateway can be easily done of the video and audios and all the channels on. Any questions on this? Simple enough? So they wanted to simplify the networks. They say, okay, now we have this, and then they review the ST2110 models, and they say, oh, how can we make better? So they added a more gateway to it. They added more gateway to it. They added more connections to the other side of the world, because people still lives in a SDI world. People still wants SDI world. The easy way, remember the first slides I said BNC to Cat5. If you can find that device, that will change the world. I think the next seminar is about Riddle. Riddles they do make a lot of converters, SFPs, to convert all your signals straight into ST2110. So the way you can do it is through the Riddle, or you can do it through the SFPs. So SFPs are directly installed in our studio cameras or our PTZ cameras, and you can actually take the ST2110 out of the cameras directly. So now you can control it, you can view the video, everything over the ST2110. Oh, this is wrong way. So this is the simplifications. So beauty is on ST2110, if you are following the standard, whether you are ISO recorders like replays, or you are just graphics, or PTZ cameras, or RTSP stream coming in, or you're transmitting to the gateway. So everything can be done over ST2110. You can bring in audio. It does support AES 67, but not Dante. Dante requires a separate network, so it's not merging. So Dante has now converter built into their software to convert Dante into AES 67 directly. I think I saw a YouTube video on it too, how to do it. So that makes it easier. So almost no gateway. If you have a HD, you can get away with 8 gigabytes SFP. If you are 4K, you need a 25 gigabytes SFP. If you're doing JPEG access, you can get away with 10 gigabyte SFP. So difference in a SFP size, you can actually transport your video and audio over the networks using the different SFP or different conversion tools. You can have a simple SDI to convert it into Cat5 networks, simple by just one converters. So there are, I think, the company name, it will skip my brain now. But there are many converters available. Aja does one, then there is a Multidyne does it, I think, and then Metrox. Metrox is a good converter. So that we have tested them for SDI to the 702110 conversions. I think they charge you for the licensing for it, but it can actually convert it much easier. So this becomes an easier workflow. So all the new facilities, like one in a Capitol Arena in Washington, DC, is done with the Kairos in 2110. So if you're building a new facility, it's easier to keep it on a ST2110. So all your facilities, all you're doing is network routing it. So if you have software-based network switch, you can manage your network switch over the network, and you put the 100 gigs Cat5 everywhere or fiber everywhere, then you're good to go. The beauty is in ST2110, the video that comes in from the gateway, from the camera or something, that requires a higher bandwidth depending on the video. If you're, as I mentioned, if you're doing HD, you need a less than 8 gig SFP. If you're doing a 4K, you need 25 gig SFP. This is non-compressed video, so there is no delay or anything. So if you have those video at that time, but routing the video can be done with a 1 gig switch. That's the beauty of it. So you can route the video anywhere you want, and whenever you wanted to post it on the outside part of it, that's when you take the 100 gig video and put it on, or whatever, 25 gig on the output side. But routing is mostly done on a 1 gig network. So in our Kairos, for example, is basically there are 2 NICs, one for 100 gigs for bringing in all the media. That's cameras, your ISO recorders, or your replays, or graphics, or everything you comes in on a 100 gig input source, and you're managing all that on a 1 gig switch. So you can route all the switches and everything over 1 gig. That's the beauty of it. And that's the reason people love that. And other part with the SDI was the synchronization part. Remember the Genlock? Still 30 hertz. Even in the composite day, you used to use black burst. With SDI, we still use the black burst. ST2110 requires synchronization from PTP. So PTP is a phase time lock. So it's clock based, and every signal, audio, video, and everything will be synchronized with the PTP. So it's very important. ST2110, in order to operate that system, you need a PTP clocks. So that's the requirement to lock each signals. You must have PTP clocks. Oops. This is an example of ST2110. You can have all ISO recording straight up on one rack unit. You don't have to run 24 SDI cable to fit it into it. All you do is 100 gig, put it in. Now you're recording all your ISOs over the network into one unit. You can playback, use this as a playback too. There is a Telestream is right next to my booth in Panasonic, and he just mentioned that they do the same thing. They also have a ISO recorder and players on ST2110. So all the companies are now trying to make this, instead of connecting all ISOs for recording, now you just put it into the network system and you can isolate, route it, all the videos straight for the router. This is the power of ST2110. It just makes it much easier to integrate or expand your systems. You can have, another 25 systems on it. As long as your network switch can handle it, you can handle it. Before, you have to buy another SDI routers, you have to buy all the units different, everything has to be different. Now, this makes it all combined into one, just to give you an idea. That's the Panasonic Kairos systems, KC2000 model numbers, and you can have two different primary and network and a secondary switch. One is a 1 gig switch for routing the video, and one is your regular 100 gig switch to bringing in the videos. So you can have both. Also, there are SDI options available. So if you don't want to convert your SDI into the 2110, you can actually plug in SDI directly into the Kairos. The second option is you just, instead of plugging it into the Kairos, you can just bring in the SFP with a 100 gig switch and plug it into it. Now you're networkable, or you can be SDI, any way you like. And also it will accept your, as I mentioned, NDI or SRT. But this system is basically a non-compressed system from end to end. So if you're bringing NDI or SRT, you have to decode it and then use it. So you have to uncompress it. And that's the reason there are limited NDIs or SRT inputs, because more NDI or SRT inputs you bring it in, more decoding you have to run on a software instead of hardware. So that's the reason it makes it much easier to run the NDI streams on. Okay. That is a live view that has an NDI SRT, and they can also run ST2110 out of that live view. So now all your streams are converted into ST2110, and you put it into the system. So live view becomes now a part of the systems for ST2110. Any way you like to bring it in. We have a new studio camera CCU came out. That studio camera CCU also has 2 SFPs to bring it in, right ST2110 into it. So now you don't need to connect all this 4K output and transcoding and bring it in, return video, and everything can be done through the SFPs on a network managed switch. So this CCU will do your stream from NDI or SRT comes in into through this. It also has a Dante audio. You can also bring it in. So Dante network is there, and this SFP for connecting everything else. And you have one LAN networks, and for controlling the CCU, one LAN network for trunks. So if you have CCU on a trunk, then, but everything goes on the network. So no longer STI, it becomes converted into STI into. Also we have ST2110 fibers. So all the 12G STI cables that need it, you don't need it. Now you can connect straight fibers into the cameras, and you can bring in everything. You see all the standards are there. Return, trunk, palm touch, everything on a network, ST2110. You can also do this, your regular ROPs. One more examples. So NDI SRT coming out of the network. This is the SFP. So SFP is in the back. Sorry for the bad pictures, but that's the SFP cage there. You can put HD SFP, you can put 4K SFP, or you can put simple video SFP and don't do ST2110. It does not matter. You can put any one of that. So now you don't imagine that you just have one SFP. You can also put a SFP with a Cat5 on it. You put it on a network and forget about it. You have all your video, you have all your control, you have all your audio, everything coming out of one port. Makes it much easier to integrate this into the systems than before. This also has one compressed output. So if you wanted to put a 10 gig SFP on it instead of 25 gig uncompressed, this particular camera will not take 25 gig SFP. So you have to go 10 gig SFP. So when you're going 10 gig SFP, your 4K video needs to be compressed with the JPEG access. Anybody knows JPEG access? It's a very light compressions, and it has a choice of compression, 5:1 compressions, 8:1 or 12:1, and depending on your choice of compressions, the bit rate will be there. So you can use the compressions. This is similar to TICO that long time ago was there. So that's the compressions. IPMX has no PTP. ITMX was like HDMI. So it has an EDID and identification and auto detects and everything. ST2110 was not like that. So it didn't have that. So ST2110 requires the PTP, but if you have a PTP, you can actually adapt IPMX also. Last but not least, SRT and RIST. Those are the two streaming format. Again, they stream from, it's one directional, so you basically streaming from the camera to the source, source to the destination, and that's it. This was very useful. SRT becoming much more powerful than RIST in the marketplace. I don't know for what reason, because SRT is a proprietary format and our RIST is open source, but somehow SRT works more than. And final thought. So expect to use combination of ST2110 LAN and WAN streaming. So both is possible. So they wanted to bring in ST2110 and they wanted to bring out the streaming output of the Kairos. And the latency requirement, whenever you have a compression like NDI or SRT, then you have a latency in the system. So please be aware of it. And as the IT network grows, the network switches become cheaper and cheaper. It's get better and better. Put fiber everywhere. And they're cheap. Surprisingly, prices has gone down and reliability has gone up on a fibers. That's true. So as long as you have fiber, whether you put video on through it or whether you put ST21 through it, does not matter. Okay? That's it. Any questions? Good? Thank you.
Digital Video Group will